Yesterday, GCP announced a very exciting new product called Cloud Run. It's a service that allows you to convert any backend code written in any programming language with any dependencies into a serverless function. This means you can deploy fully managed microservices that will scale automatically while only paying for the actual resources that you use. In today's video, I'll show you how to take a server-side rendered JavaScript application, containerize it with Docker, deploy it to Cloud Run, and then hook it up to Firebase hosting. If you're new here, like and subscribe, and you can grab the full walkthrough from Fireship.io. I'm really excited about Cloud Run because it's the service I've been wishing for ever since I started working with serverless functions. The single biggest problem with serverless has always been the limitation of the runtime. Most cloud providers only offer a few different programming languages, and if you need any special dependencies in your runtime, then you're basically out of luck. Your only real option at that point is to provision a virtual machine or use something like App Engine to deploy your code. And those resources are always online, which means you're always paying for them, and you also have to worry about scaling them up and down. Cloud Run is basically the best of both worlds and really the future of cloud computing in general, in my opinion. All you have to do as a developer is write your code and then wrap it in a Docker image. The one thing to keep in mind though is that your code needs to be stateless. In other words, you can't be saving permanent files to the file system or be running a SQL database and expect to have access to that data later. That shouldn't be a problem because you should be building stateless applications anyway, while using things like cloud storage, Firestore, or Cloud SQL to manage your persistent data. Now let's take a look at a few things that you might want to start using Cloud Run for. The first thing is server-side rendering JavaScript applications. I'm going to show you how to do this with Nuxt.js and Vue, but the same principles apply to Angular Universal or Next.js with React. You could also hypothetically use it to build a more traditional web application like say WordPress or Ruby on Rails, as long as you keep the database outside of the container. And I find this one really interesting because that means you could have a WordPress site hosted on Firebase hosting. And another use case for Cloud Run would just be to create RESTful APIs or even GraphQL APIs. And feel free to do it in whatever programming language you want. Now let's go ahead and take a look at a full example from start to finish. We're going to take this Nuxt.js app, which is just a Vue app that's server-side rendered with Express.js. We'll create a Docker image for it and then deploy it as a microservice to Cloud Run. And as a final touch, I'll show you how to integrate it with Firebase hosting. To follow along with this lesson, you'll need to have Docker installed on your local system as well as the Google Cloud SDK. First, we need to create an app or a microservice that we can deploy. I'll be using Nuxt.js for this demo, and the reason I chose Nuxt is because it's really easy to get started with server-side rendering. From the command line, we run npx create Nuxt app, and then it will give us a handful of options that we can run through. Mostly we'll just select the defaults here. The only important thing is to select Universal as the rendering mode. From there, we can open it up in VS Code and then run npm run dev to serve the app locally. That's just running an Express.js server with Node, and you should see something that looks like this in the browser on localhost 3000. I'm not going to spend any time changing the underlying Nuxt code. It's already ready to go. We just need to Dockerize it. I'm not going to get into the fundamentals of Docker in this video, but you can think of an image as an executable of your application. We create this image by defining a Docker file, and in that file we define a series of steps required to build the actual virtual machine or container that runs our code. So even if you've never used Docker before, it's actually very intuitive and easy to write a Docker file because you're basically just doing the same things that you would normally do from the command line to run your app. Go ahead and create a Docker file in the root of the application, and the first step in any Docker file is to define the base image. This is usually just a minimal operating system like a Linux distro, or in our case, since we're building a Node app, we'll use the Node 10 image, which is just a Linux distro with Node version 10 installed. You can think of the steps in a Docker file similar to the steps that you would run from the command line. For Cloud Run, we're going to set the working directory as user source app. That's kind of like CDing into a directory, and then we'll set an environment variable called port. This environment variable is very important in this case because Cloud Run's going to be looking for this port and expose it so you can actually interact with the service after it's deployed. And we'll also define a host environment variable because Nuxt will be looking for the host and the port to determine how to serve the app. The next thing we'll do is copy the package.json files into the working directory, and then we'll run npm install only for our production dependencies. From there, we'll copy all of the source code from our local project to the working directory. Then we'll run npm build to build the production Nuxt app, and then npm start, which is the command that actually starts the service in this container. So that's our entire Docker file. Now that we have that complete, we want to build the image itself. We can run docker build and then point to the directory that contains the Docker file. That's going to build out the image in a series of steps or layers. And now Docker knows how to reproduce our code so it can scale to an infinite number of containers. After that's done, you'll notice it gives us an image ID down here at the bottom. You can use that ID to run the container locally, which is generally a good idea just to make sure everything's working before you deploy it. You can do that with Docker run, and then you should see the same Nuxt app being served on localhost 8080. Now that we know that everything's working properly, we need to tag this image and then upload it to the container registry on GCP. We can do that by first running docker tag, followed by the image ID, and then followed by gcr.io/your project ID/whatever you want to call this service. That associates the image with this URL, then you can run docker push to actually upload it to that URL. That's going to take a few minutes, but when it's finished, you can go to the GCP console and see it in the container registry. And just a side note, you can use Cloud Build to entirely automate this process if you don't want to do it manually like I just showed you. And I made a video all about that a few weeks ago. The next step is to take this image and deploy it as a microservice with Cloud Run. Head over to the container registry on GCP and verify that the image that you just uploaded is available there. From there, head over to Cloud Run, and we'll create a new service by clicking on the Create Service button. That will give us the option to select a container image URL, which we can do for our Nux server. Then just give it a name and a location, and then make sure to check the button for Allow Unauthenticated Invocations. This is a public app, so we want anybody to be able to access the service. It'll take a few minutes to finish, but when it's done, you should be able to see the logs coming from the container. And then you'll see a URL that we can use to access the service over HTTP. And if we open it in a browser, we should see the same exact Nuxt app that we were working with locally. Now at this point, we could map the service domain to our own custom domain, and that can be done directly through the Cloud Run console. But Cloud Run is also integrated with Firebase, so we can actually map this service to our Firebase hosting account. At this point, I'm assuming you have the Firebase command line tools installed, then run Firebase init hosting from inside of the Nuxt app. You can select all the default options, then choose no when asked if it's a single page application. Firebase will automatically create a public directory. You'll want to go ahead and keep that directory, but delete the index.html that's inside it. Firebase hosting will give a higher priority to this index.html file than it will to rewrites. And what we're actually doing here is rewriting all of our traffic to that microservice endpoint. We do that by going into the Firebase JSON file, add a rewrites array, and then define an object that has a property of source, which points to **, which will just capture all of the routes in this app. And then a second property called run, which will point to the service ID or the service name that we defined in Cloud Run. From there, we just need to run Firebase deploy only hosting, and now we have a Nuxt app deployed to Firebase hosting with full server-side rendering. And like I mentioned earlier, you can do the same thing with Angular Universal or React Next or whatever you want. But more importantly, Cloud Run basically removes all the limitations that we used to face when building serverless apps. I'm going to go ahead and wrap things up there, but expect more Cloud Run videos in the future because it opens the door to all kinds of interesting possibilities. If this video helped you, please like and subscribe, and consider becoming a pro member at Fireship.io to get access to even more content. Thanks for watching, and I will talk to you soon.